I'm out here at COSI with Joe Wood. We're all gloved up for some magic.
Yes, we're gonna do, so this is an example of a optical, of a physical optical illusion. So normally optical illusions are things like involving your eyes or your brain. We're actually gonna be using the properties of light to trick our eyes.
We're so sciencey today.
Yes, so I'm not gonna tell you exactly how this works, I'm just gonna show you.
All right.
So I've got my beaker.
Yep.
And then there is a flask inside the beaker. And as I pour this oil, I have made the beaker disappear.
Magic. Oh, that's wild.
You can just kind of see the outline of the flask if you're really looking for it. Because there's that slight angle change.
Cool.
So what we're doing here is we're talking about refractive index. So everything has a refractive index. Water has a different refractive index than light. So the light actually travels more slowly through it. So you've noticed this when you've seen like a straw in a cup or a pencil like this and it looks like it's bent. Obviously it's not bent and that's why this is an optical illusion. But because the light is traveling more slowly through the water, it's passing to our eyes more slowly than the light passing through the air here. And so it looks like the pencil is bent. So we're manipulating that, and I'll let you have your turn here. So you just want to pour the oil into it. It's got to be inside and outside.
Inside and outside.
So just so the folks at home can see, we're not cheating.
All right.
So the refractive index of this kind of vegetable oil is the same as...
That's why we have the thing.
That's why we have the dump in there. It's the same refractive index as the glass.
That's so cool.
Now, if you wanted to do this at home, now you can see the lines are the only way that we can tell that there's a flask in there. And if you want to, you know, you can kind of pull it out to see what's going on here. Now, if you wanted to do this at home, you would be looking for, not an ad, but this brand of vegetable oil happens to have the same refractive index as this glass. Now, you might not have lab glass in your house.
I see, yes.
But you might have Pyrex cookware.
I do.
Which is called a borosilicate glass. It's the same kind of glass. And so you may have to, it may work right the first time, but it'll be a true experiment. You'll have to maybe experiment with a few different kinds of oil.
Find the right glass.
Or even mixing a few different kinds of oil to find the right refractive index.
That is so cool.
Another example of this would be like those Orbeez, the little balls that fill with water. The plastic outside has the same refractive index as water, so they kind of disappear in a thing of water.
I love that. So much fun. And we're talking a lot about water because you have a couple of different things happening here. But one is like all about folks that are living in the water.
Well, we're thinking about the water, as you said, because we do have our ocean exhibit, but we also, on the other end of the hallway, down by the Dinosaur Gallery, have our American Museum of Natural History traveling exhibit all about sharks. And that's a really cool exhibit. The main part of the exhibit is all these life-size models of different species of sharks.
Oh, awesome.
Including a few extinct ones. There's also some fossils. And so you can imagine yourself under the water, which is something that divers have to understand refractive index for.
Very, very cool. Joe, thank you so much. Try this at home. And then, of course, swing by COSI to check out sharks.